So today's video, we're continuing to practice factoring, but today we're specifically looking at factoring with a negative constant. So that would mean that in the form of our standard form, ax squared plus bx, our constant is going to be negative, so minus c. This may or may not result in our b term being negative, but we're specifically looking at factoring with a negative constant term. The simple rule for this is that whenever we have a negative constant, so that c value being negative, one of our factors must be positive and one of our factors must be negative. So this is just the rule. Other than this, we follow the exact same steps as we did last class. So something that will be helpful is if you pull out your notes from last class and your steps for factoring. So we're going to go through an example here. So we have x squared plus 2x minus 24. So just like usual, the first step, we want to identify our b and c values. My b value here is positive 2. My c value here is negative 24. So the reason why I know that I need one factor that must be positive and one that must be negative is because if I have a negative constant and I know my two factors need to multiply together to be the c value, if I had two positive numbers multiplying, we would not get a negative. If I had two negative factors being multiplied, we also would not have a negative constant because a negative times a negative is positive. So one must be positive and one must be negative. So when they multiply together, I do get this negative c value. So what I'm going to do is I'm going to use my factor sheet. This factor sheet is linked in the PowerPoint for you. And I'm going to look and identify all the pairs of factors for c. I'm looking just at the absolute value of c right now, and then we'll figure out the negatives later. So I'm just looking at 24 on the factor sheet. The factor sheet does not have negatives. So my pairs of factors for 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So I've listed out all my pairs of factors for c. And using our rule, we know that one of the factors is going to be positive in the pair and one must be negative. So for example, out of 1 and 24, one of them has to be positive and one has to be negative. And we're looking for a pair that then, with one being positive and one being negative, will add up to my b value of 2. So we're going to go ahead and check them. So what we're going to do is let's just go ahead and play around with it. I can take turns assigning negatives to each value. So is negative 1 plus 24 2? No, it's not. If I then flip it around and I do negative 24 plus 1, is negative 24 plus 1 2? No, there's no way I can combine those two numbers, negative or not, and get the b value of 2. Another method of doing this is simply taking turns subtracting each from the other of the pair of factors and looking at it that way. So 12 minus 2, that's like adding 12 and negative 2. So is 12 minus 2 2? No, that would be 10. Is 2 minus 12 2? No, that would give me a negative b value. So this one doesn't work either. Is 8 minus 3? So that would be like combining 8 and negative 3. 2, no, that's 5. And what about 3? Positive 3 minus 8. Positive 3 minus 8 is also not 2. So this pair does not work. What about 4 and 6? So if I do 6 minus 4, that does give me 2. So I see here that my pair of factors are this 4 and 6 here, and we know one needs to be negative and one is positive. And it works if my 4 is the negative value. 6 minus 4 is 2, okay? Or 6 plus negative 4 is 2. So this is my pair of factors. I have a negative c value. I meet my rule that one is positive and one is negative. And all I'm going to do simply, I'm just going to label my a, my factor 1 is negative 4. My b, factor 2 is 6. And then I'm going to fill it in. So I have x plus negative 4 as 1. And I have x plus 6 as the other completed factors. So to simplify this or rewrite it so it's neater, x plus negative 4 is the same thing as x minus 4. And then we have x plus 6. So notice in this factored form here, we have a negative and a positive sign. That's exactly what we need whenever we have a negative constant. We'll always have both signs. Last step is to check our work. So I have x minus 4 times x plus 6. And I'm going to distribute to make sure that it matches my original function here. So I have x times x, which is x squared. I have x times positive 6, which is 6x. I have negative 4 times x, which is negative 4x. And I have negative 4 times 6, which is negative 24. Combining like terms here, my values here both being multiplied by x to the first power are like terms, so I can combine them, and I have x squared. 6 minus 4 is 2x, so positive 2x minus 24. And after I distribute, I can see that it does, in fact, match. So my factored form here of x minus 4 times x plus 6 did work. This is my final answer for putting my standard form into factored form. So again, notice how you follow the exact same steps that we learned last class. The only thing is you're going to have to play around with your pairs of factors. Practice adding them while taking turns with one being a negative and one being a positive until you find that pair that will successfully add up to b while one of the values is negative and one of the values is positive. All right, so that's it. You're going to actually do 3 practice problems on your own. Please see me in Google Meets if you're struggling, or feel free to watch this video again.